Alright guys, so in this video we are going to talk about the derivatives of the other four trig functions. We said in class that the derivative of sine x is cosine x, and the derivative of cosine x is negative sine x. And one of the things we know about the other four trig functions is that each one of the other four trig functions can be represented with sine and cosine. So our strategy for getting the derivatives of the other four trig functions is going to be to represent them with sine and cosine and then take the derivatives from there. So right here we'll start out with cosecant, and we know that cosecant can be represented as 1 over sine x. Now from here, we can take the derivative with the quotient rule. So right here we can say that our dy dx is going to be our u prime times v. U prime is going to be the derivative of the numerator, which is going to be 0. And our v is going to be our denominator of sine, minus our u v prime. And of course our u is our numerator of 1, and our v prime would be the derivative of the denominator sine, which is cosine. Now right here that's all over sine x squared. And from here what we want to do is, of course, get our derivative in a more usable form. So right here we're going to say that we can simplify that numerator. With our first term we're multiplying 0, so that first term is going to go away. And we can say that our derivative is going to look like this: negative cosine x over sine x squared. Now we can do a little bit more simplifying here. We'd like to see our derivative in terms of trig functions just in the numerator. So what I'm going to do here is I'm going to factor away one of the divisions of sine x and call this negative 1 over sine x times cosine x over sine x. Now right here, I can say that that negative 1 over sine x is going to be negative cosecant x, and my cosine x over sine x is cotan x. And there is the way we are going to represent the derivative of cosecant x. So right here, what I want you guys to do is to go ahead and give secant a shot. We're going to follow pretty much the same steps. So right here we can represent secant as 1 over cosine x, and then you guys are going to go ahead and take the derivative with the quotient rule from there and follow the same steps for simplification. All right, guys, so we'll pause the video here and we'll come back and look at this in a second. All right, guys, so right here we've got our secant x as 1 over cosine x. And when we take the derivative with the quotient rule, we say the derivative of the numerator is 0 times the denominator is cosine, and then minus our numerator of 1 times the derivative of our denominator, negative sine, over cosine x squared, right? And then we can start to simplify from here. We've got 0 times cosine x, so that's going to go away. And we've also got our subtraction and our negative sign with the negatives canceling, giving us just sine x in the numerator. So right here we can say that our derivative can be written in the form sine x over cosine squared x. And right here we can factor one of the divisions of cosine out, giving us 1 over cosine x times sine x over cosine x. And then right here we can, of course, rewrite our derivative as secant x times tan x for secant. So right here, the derivative of secant is secant tan. Now right here, we're going to take a look at determining the derivatives of tan and cotan. I'm going to go ahead and do cotan, and then I'm going to let you guys do tan. So right here with cotan, we can say that cotan can be written as cosine x over sine x. And here again, we can take the derivative with the quotient rule. So we can say our dy dx is going to be our derivative of our numerator, so that's negative sine x times our denominator of sine x, and then minus our numerator of cosine x times the derivative of our denominator. The derivative of sine x is cosine x. And that's over sine squared x, or sine x squared. Now right here, in the numerator, I can see that I have a multiplication of sine and sine, so I can call this negative sine squared x. And then right here, I've got a multiplication of cosine and cosine without subtracting away, so I can call this minus cosine squared x over, and then right here I can say I've got sine squared x there. Now right here, we're pretty close to our Pythagorean identity of cosine x plus sine x equals 1. But the problem is that both of our terms are negative. But we can solve this by factoring a negative out of the numerator. So we can call this negative sine squared x plus cosine squared x in the numerator, being divided by sine squared x. And now right here, that sine squared x plus cosine squared x is 1, so we have negative 1 over sine squared x. And now right here we can say negative 1 over sine squared x is going to be a derivative of negative cosecant squared x. So there's our derivative for cotan, negative cosecant squared. And I'm going to let you guys go ahead and get the derivative for tan now. Again, a lot like our last two problems, the derivatives for cotan and tan are going to be very similar in terms of the ways that we get them. So why don't you guys go ahead and pause the video here, and we'll let you give the derivative of tan a shot, and we'll come back and look at it in a second. All right, guys, so right here we have our tan x as sine x over cosine x, and when we take the derivative with the quotient rule, we get the derivative of the numerator, cosine, times the denominator of cosine, minus, and then our numerator of sine times the derivative of our denominator. Oh boy. All right, guys, so looking at tan x, we can say tan x is equal to sine x over cosine x. And when we take the derivative, looking at our tan x, we can say tan x is equal to sine x divided by cosine x. And when we take the derivative with our quotient rule, we can say that we have our derivative as the derivative of the numerator, cosine, times the denominator of cosine, minus the numerator of sine times the derivative of the denominator, negative sine, over that cosine squared in the denominator. Now right here, again, a nice thing that happens for us is we have that subtraction and the negative sign canceling, giving us a plus sine squared x in our numerator. So our numerator is now cosine squared x plus sine squared x divided by cosine squared x. And right here we can make that Pythagorean substitution for the numerator here and get 1 over cosine squared x as our derivative. And right here we can simplify that to secant squared x as the derivative of tan x. So right here on this next page, we've got some problems. I figure we might talk about them a little bit, and then I'd let you guys try them, because I think you're probably ready to go ahead and give some of these derivatives a shot. So right here, we've got all the derivatives for our trig functions above, and looking at these functions, we can go through and talk about the strategy a little bit. For this first guy, a, we've got y equals x squared times secant x, and of course right here we're seeing a multiplication, which means that we're going to want to use the product rule. So right here we would say our x squared would be our u, and our secant would be our v, and we take the derivative with the product rule there. Similarly, with v, we've got tan x times sine x, so right here we can say we've got our tan x as our u and our sine x as our v, and again we want to take the derivative with the product rule there. In c, we have a division, and clearly you're going to want to take the derivative with the quotient rule here. where our u is going to be cosine x and our v is going to be 1 minus sine x. Now right here with d, we could take the derivative with the quotient rule, but there's also a substitution we can make with the Pythagorean identity that is going to make this a little bit easier. And of course, we can sort of hint towards that in writing our 4 over cotan as 4 times 1 over cotan x. And from there, you can ask yourselves, is there an easier derivative I can take? So right here, why don't we pause the video and let you guys give these a shot, and we'll come back and look at them in a second. All right, guys, so let's take a quick look at these. We've got our product rule with x squared and secant x, and so right here with x squared as our u and secant x as our v, we would say that our derivative is u prime of 2x times a v of secant x plus a u of x squared times a v prime of secant x tan x. Moving on to b, right here we've got another product rule with our u as tan and our v as sine. And right here we would say our derivative is going to be u prime of secant squared x times a v of sine x plus a u of tan x times a v prime of cosine x. Right? And that's good enough for these derivatives. I mean, there's more simplifying we can do with identities and canceling, but we're good enough with our derivatives here for now. And we'll talk a little bit more about simplifying later. So right here for C, we've got our quotient rule where our numerator is our cosine and our denominator is our 1 minus sine x, right? So with a numerator u of cosine and a denominator v of 1 minus sine x, we can say our derivative is going to be our u prime of negative sine x times our v of 1 minus sine x minus our u of cosine x times our v prime of negative cosine x, and that's over 1 minus sine x squared. Now right here with d, we've got a little bit of two ways that we can look at it. So first what I said was let's look at it head on and attack it like a quotient rule. And right here, if we do that, we get the derivative of our u of 4 as 0, and right here times our v of cotan minus our u, so that's u prime, and then right here, here's our v, and then minus our u of 4 times our v prime of negative cosecant squared, and that's over cotan squared x. And of course, this 0 times cotan becomes a 0 term, and our negatives cancel out, so we can think about this as 4 cosecant squared x over cotan squared x, and that would be good enough for the derivative, but we can also do more simplifying. So right here, we can change our cosecant squared x to 1 over sine squared x, and we can change our cotan squared x to cosine squared x over sine squared x. Now right here, dividing by a fraction, we can change this to multiplying by the reciprocal, and our sine squared x's will cancel, and then we've got 4 times our 1 over cosine squared x, and right here, 1 over cosine squared x can be written as secant squared x. So we would say that our derivative in its most simplified form would be 4 times secant squared x. Now, if we'd gone up at the very beginning and changed that 1 over cotan x to a tan x and attacked our derivative from the equation in the form 4 minus tan x, we would say that we would have the derivative of a constant times a function as the constant times the derivative of the function. And right here, that would give us 4 times secant squared x as the derivative of 4 times tan x. All right, so on our next page, we've got some more complicated problems, or more involved problems, I would say. And I'd like us to take a look at these. Right here, we can talk about strategy first. So for our A, we've got y equals x squared over sine x times cosine x. So right here, first we're going to say this is a quotient rule, right? Because we've got a fraction equation with our numerator u of x squared, and our denominator v of sine x times cosine x. And then in that denominator, we're going to have a product, which means that when we take the derivative of that denominator, we're going to have to use the product rule. Now, this next guy is a little bit more involved. So right here, what I'm going to say is if we rewrite this guy as x to the fifth times tan x times x to the 1/2 power, we can say that really we have a product of 3 terms, right? And for right now, what I'm going to say is that if we think about multiplying common bases, right, we can say that a multiplication of common bases is an addition of exponents. So right here, we actually have y equals x to the 5 plus 1/2 times tan x. And right here, from there, we can say that our x to the 5 plus 1/2 would be y equals, and I might even write this as x to the 5.5, right? And our x to the 5 plus 1/2 can be written as x to the 11 over 2 times our tan x. Now, next class we'll talk about how to attack this guy directly with an extension of the product rule. But for right now, we'll go ahead and say that we can rewrite our b function as y equals x to the 11/2 times tan x. And we'll go ahead and attack it as a product rule like that. So next right here we have our c as y equals 5 times the square root of x plus 6 divided by the cubed root of x to the 4th minus 2 times cotan x. And right here, of course, we're going to rewrite this before we take the derivative. And then right here with d, we have 20 times x cubed minus 6 secant x cosecant x. Now right here, what I'm going to say is, let's let that 6 be a part of our u for our product rule, and we'll say our v is going to be our cosecant, and we can attack the derivative like that. Remember that when we have the derivative of a constant times a variable expression, that our derivative is going to be the constant times the derivative of that variable expression. Or we could think about this as the derivative of a constant times the function is the constant times the derivative of the function. So when we take the derivative of our 6 secant x, it's really just going to be 6 times the derivative of secant x when we take that derivative of u. All right, guys, so let's pause the video here, and we will go ahead and attack these problems, and we will come back and look at them together in a second. All right, guys, so let's bust through these. With our a, we have our quotient rule. And right here we would say that our u prime is going to be 2x times our v of sine x cosine x, so 2x times sine x cosine x, and then minus our u of x squared, and then times our v prime, and here we had to use the product rule, so it's our derivative of sine as cosine times our cosine plus our sine times the derivative of our cosine, which is negative sine. I did some simplifying from here, just sort of multiplying out negatives and combining some terms right here. I said for my dy dx in the end, I would write it as 2x sine x cosine x minus x squared, and then times cosine squared x minus sine squared x, and that minus came from that negative sine x right there over, and then it's our denominator squared, so that's sine x times cosine x squared. So there's our derivative of a. For b, we said we were going to take the derivative from our y equals x to the 11th, from our y equals x to the 11th from our y equals x to the 11 over 2 times tan. And so right here we've got our u and our v with our product rule, and when we take the derivative, we have dy dx as 11 halves x to the 9 halves times tan x. So that's our u prime as 11 halves times x to the 9 halves, and our v as tan x, and then times our, all right, and then plus our x to the 11 halves times the derivative of tan x secant squared x, and that's our u v prime. Just a bit dummy. Bit off a little more than a good shoe. I added it too dummy. All right. For our b, we said we were going to take the derivative from our product rule of x to the 11 halves times tan x. And right here, we'd say that our u prime is 11 halves x to the 9 halves times our v of tan x, and then it's plus our u x to the 11 halves times our v prime of secant squared x. And right here we would do the simplifying that we always do. One thing I did here is with those fraction exponents, I basically wrote them behind the trig functions. And that's generally the order in which you'd write things. So right here I have 11 halves tan x times the square root of x to the 9th, and then plus secant squared x times the square root of x to the 11th. Okay, so for our c, we have right here our list of terms we're taking the derivative of, and we want to go through and take the derivative with just the power rule where we can. So right here we will write that square root of x as x to the 1/2, and we will write that that cube root of x to the 4th in our denominator as x to the -4/3. And when we take our derivative, we're going to have our derivative of our 5x to the 1/2 as 5 halves x to the -1/2, derivative of our 6x to the -4/3 as -12x to the -7/3, and then right here the derivative of our 2 cotan x as positive 2 cosecant squared x. And that's what that last term should be. So right here, simplifying this, we have our dy dx as 5 over 2 times the square root of x minus 12 over the cube root of x to the 7th, and then right here plus 2 cosecant, plus 2 cosecant squared x. Now finally with this last one, we have two terms, right? We can take the derivative with the power rule for that first term, and then that second term we're going to have to take the derivative with the product rule. So right here, when we take our derivative, we will say the derivative of 20x cubed would be 60x squared, and then we're subtracting away this product rule. So right here, we have our u as 6 secant x, so right here our u prime is going to be 6 secant x tan x. And then right here times our v of cosecant x, and then plus our u of 6 secant x times our v prime of negative cosecant x cotan x. And right here, I just sort of multiplied out the positives and negatives and just distributed by -3. So I multiplied this term negative. So right here, I multiplied my negative cosecant x cotan x times my 6 secant x, and then I distributed the negative through. So that gave me 60x squared minus 6 secant x tan x cosecant x plus 6 secant x cosecant x cotan x. And of course, there's more simplifying we can do with identities, but for right now, just going through the process of taking the derivative, this form is good enough for us. All right, guys, so this is our video. We'll do some worksheet next class, and I will see you then.